Hello dear students, today I will continue the derivative topic. Just in the previous class we have completed the derivative by finding derivative by first principle method. Here also there are method for finding derivatives of some uh, expression just like polynomial and mixing function. We can use algebra of derivatives. Algebra of derivatives means algebra of derivatives means just like a limit, the limit of addition of two function, subtraction of two function, product of two function, division of two function. Here also derivative of addition of two function, subtraction of two function, and product of two function and division of two function can be found by using formula. Here multiplication formula and division formula very important for finding derivatives of an expression, polynomial, etc. Okay, so here just if fx and gx are functions having common domain, okay, then because we have to find the limit of the expression involving fx and gx, and so they should be defined in a common domain. So fx and gx are functions having or defined in a common domain, having common domain. Then first of all, just derivative of addition, just like this fx plus gx, addition of two function, we can find by just distributing like this, dy dx fx plus dy dx gx. Okay, first. Similarly, subtraction also, dy dx fx minus gx equals to dy dx fx minus dy dx gx. Okay, derivative of this, just distributing. Now third point, what? Derivative of multiplication of two function. Derivative of multiplication of two function, fx into gx. Multiplication of two function. Its formula is just different from limit. Here, just we have to use this formula. There are product of two function. So derivative of first function into product of second function plus in reverse order. First function into derivative of second function. This is the formula. That is, in short, we can write u, v or two function, suppose. Then we can write its derivative, u, v. Just this is u, this is v. U, v dash derivative can be written as like this: u dash v plus v, u, v dash. In short, you can write like this. Okay? Just like see, x sin x. This is function, and we want to differentiate it. We want to differentiate it. So we can differentiate. This is first function, this is f, this is g. Then you can differentiate. First differentiate it, take as it is, plus take it as it is and its derivative. Okay, so we will use this formula, product derivative of product of two function. Clear? Product of two function. This is very, very important formula. Okay, so algebra of derivatives, derivative of addition of function, subtraction of function, product of function. Product rule is this. This is the product rule. Also you can see product rule. Product rule for derivative. Okay, this product rule for derivative. Okay, now fourth is division rule. So division rule is also very, very important formula. Okay, so this two formula we will use. This is product rule. Fourth, division rule. For derivative. Okay, so note down this formula, product rule. We will solve some questions from this by using this rule later on after discussing the formula, all the formula. Okay, so here see this. D by dx of fx upon gx. Suppose there are function is rational function like this, fx by gx, but gx is not equals to 0. Here gx is not equals to 0 in domain. Okay. Clear? Here this is not equals to 0. The formula is what? Just note down this formula, very, very important formula. Gx square, denominator square, denominator gx. This is the denominator, this is numerator gx into derivative of numerator, that is fx, minus just reverse fx dy dx gx. Okay, so this is formula. Clear? Okay, so writing method is very simple. Numerator upon denominator is equals to what? Denominator square, denominator, numerator dash minus numerator, denominator dash. Just you can write like this formula, because this is in place of denominator. So denominator square, and here denominator d square d, and dash, and in reverse order, just after minus sign you can write n d dash. So its dash is this. So this is division rule for derivatives. Okay. So remember this rule also. Okay. By using this rule, we can also find the derivative of 10x, cot x, etc. So just see how can we find the derivative of cos x. We know derivative of sin x is what? Derivative of sin x is cos x. Just we have proved in the previous class. Derivative of cos x is minus sin x. Just you can verify by using first principle method. So here, just as we know the formula, derivative of sin is cos, derivative of cos is sin, minus sin. Just we will find derivative of cot x. Okay, using this formula, by using this formula. Okay, so see here, if we want to find the derivative of 10x, suppose cos x, cot x, then using division rule, we see that we want to find the derivative of cot x. Okay, then using division rule we see that d by dx of cot x, d by dx of cos x upon sin x. We can also find its derivative by using first principle method. But suppose d by dx cot x we have to find, then d by dx cos can be written cos by sin. We know its derivative and its derivative also. So just use this formula. So fx upon gx. Here gx is sin, denominator. This is numerator cos x. So we can write using division rule, denominator square, that is sin x square, denominator square denominator, into derivative of numerator, derivative of numerator, that is cos x, minus in reverse order what? Numerator cos x. Here numerator is cos x and derivative of denominator sin x. Just put the value here. Sin x into, we know, since just use since derivative of cos x equals to minus sin x and derivative of sin x equals to cos x. Just use this formula. So the derivative of cos x is minus sin x, we know. Just by first principle method we have proved sin x as cos x. So we can use these two. here. So sin x dy dx cos x is minus sin x. So here minus sin x minus cos x. Derivative of this is cos x. So cos x upon sin square x. Just we see that sin square x. Okay. Now here minus sin square minus cos square. So what? Minus sin square minus cos square. That is minus, take common, then sin square x plus cos square x upon sin square x. So sin square x plus cos square x equal to 1. So finally we get what? Minus 1 upon sin square x. That is what? 1 by sin cosec. So minus cosec square x. So this is final derivative. What is the value? This. dy dx of cot x. dy dx cot x. Derivative of cot x is minus cosec square x. Okay. Derivative of cot x is minus cosec square x. Clear? So, division rule can be used for finding derivative of rational type of function. So here if we know sin derivative of sin x and cos x, then we can find the derivative of cot x. Okay. This formula is useful. Okay. Very useful. Derivative of rational function, that is division rule, and also product rule, that is u into v. Okay. So remember these two formula. Now derivative of polynomial function. This polynomial, you know, polynomial at first where we will find the derivative of x to the power n. This is the basic formula or for derivative, finding derivatives. Okay, x to the power n. This is first formula, very useful. Just like this, derivative of x to the power n. Very important formula, basic formula for derivative, for finding derivative. Okay, so here how can you find the derivative of this function? By first principle method. By first principle method. Okay. So dy dx fx means what? Dy dx x to the power n. Here fx equal to x to the power n. Fx equals to x to the power n. Fx equals to x to the power n. That is fx. Okay. So this dy dx fx n is equals to what? Limit h tending to 0 fx plus h minus fx upon h. We know this formula. Okay. So here fx equals to, just write it here, fx equals to x to the power n. Okay, where n is what? Positive integer. Here n is any positive integer. Clear? Now, just this is first principle method. So, limit h tending to 0, fx plus h, fx equal to x to the power n, fx plus h, x plus h or n minus fx equals to x to the power n upon h. Just as suppose here n equals to 2, then a plus b whole square, n equals to 3, then a plus b whole cube, n equals to 4, then a plus b or 4 you can find by multiplying x plus h 4 times. So by using binomial theorem, since a plus b power n equals to NC0 a power n plus NC1 a power n minus 1 into b power 1, here b power 0, NC2 a power n minus 2 b square plus and so on up to NCN a power 0 b power n. This is formula. Okay, this is the formula for binomial theorem. Since using binomial theorem, we know that just you have to write like this. This is formula. A plus b power n, just like this. NC0 means what? 1. NC1 means n. And so on. Just you can write value here. Okay. So here, see, in place of a, x, in place of b, h. So just write this formula by using this formula. Okay. So NC0 means what? 1. So 1 into a power n, b power 0, h power 0, h power 0 means 1. So it can be written also like this. What? A to the power n plus n a n minus 1 b plus and so on. Last term NCN equals to also 1. So last term is b power n. So this is formula. Just write in this form. Okay. So first a to the power n. A means x. So x to the power n plus n a x n minus 1 b h plus n just NC2, right here, NC2 x to the power n minus 2 into h square plus and so on. Last value b power n, h power n, h power n. This is from binomial expansion using this. Okay, using this we can write like this: minus x to the power n, minus x to the power n. Clear? And denominator is h. Denominator is h. Okay, just we are using this formula for expanding this. Okay, now here we see that x to the power n cancel out, and here h square and up to h to the power n. So this minus this cancel out, h can be taken common. So right, this binomial theorem is very very important. Just remember it. Okay, by using this we can get the result here. Limit h tending to 0. Here taking h common in the numerator. Okay, just h common, then n x to the power n minus 1 plus nc2 x to the power n minus 2 h plus and so on up to h to the power n minus 1. Here 1h less and here h to the power n minus 1, and denominator is h. So h cancel out. So we get limit s tending to 0 n x to the power n minus 1 plus nc2 x to the power n minus 2 h plus and so on up to h to the power n minus 1. So here we see that except this term, each term will contain h, and if we put h equals to 0, then we get only what? N x to the power n minus 1, and remaining terms are 0. So this is the value. So dy dx x to the power n equal to this. This is very very important formula. Okay, dy dx x to the power n x to the power n minus 1. This is important formula. Derivative of x to the power n. So just write here, n is positive integer. So write here formula dy dx x to the power n equals to n x to the power n minus 1. Okay, this is formula. Okay, this is formula is derived by first principle method. Now by using this method, we can find derivative of different type of combination of functions. So here our particular formula is this. So just for finding derivative of x sin x by using product rule. So we know product rule also. Find derivative of x sin x by using, find derivative of x sin x by using first principle method, and second product rule. Suppose we are having this, just we have to find the derivative of these two, first principal method and also product rule. By both method we must get the same result here. Okay, so first principal method, first principal method. So let fx equals to x sin x. Then first, by using first principal method, we get derivative of fx. Here fx means what? X sin x. So limit, we know h tending to 0. What? F x plus h minus fx upon h. Clear? So this equals to limit h tending to 0, fx plus h minus fx, fx plus h, fx equal to this, fx plus h means in place of x just you have to write x plus h. So x plus h, fx plus h, x plus h, sin x plus h, sin x plus h minus fx, that means this x sin x upon h. Just now our target is what? Finding this limit. Okay, so write limit h tending to 0. We can use sin a plus b formula, since sin a plus b is equals to what? Sin a cos b plus cos a sin b. Sin a plus b formula, sin a plus b. So here x plus h into sin x plus a plus b, sin x cos h plus sin, just you can write in this direction, cos sin x cos h cos x sin h minus x sin x, this upon h. Now again expand this, limit h tending to 0, just multiply by this, okay, x into sin x cos x, just x, just multiply this two. So x into sin x cos x plus x into cos x sin h, by multiplying by x and by also by h. So plus h sin x cos h plus h cos x sin h minus x sin x. This is divided by h. Okay. Now see, x sin x, x sin x minus here. So just wait, this is a cos h, cos h. So here x sin x common. So you can write like this: limit h tending to 0, x sin x common, cos h minus 1, cos h minus 1, this and this combined, upon, also h is divided here. Now x cos x sin h plus x cos x sin h, this h is divided by, also here, x cos x sin h by h. Okay. Now here in this sin x cos s and cos x sin h, so this can be combined as plus this and this divided by this divided by this, and this two, here h can be taken common, so h, and we get what? Sin x cos h, sin x cos h plus cos x sin h upon h. So this we get. Now distribute this limit. Okay. Just our target is what? Finding limit. So now we can distribute it. First, limit. Here we see that x sin x, h tending to 0, x sin x can be taken outside. X sin x. Okay. Limit cos h minus 1 by h. Clear? So cos h minus 1 by h. Cos h minus 1 by h. This. This is first part, and limit is distributed second part. So in this second part, just x cos x, and limit h tending to 0, sin h upon h. This is the second part. And third part, h is cancelled. H cancel. Sin A cos B plus cos A sin B, that is sin x plus h. So here limit h tending to 0, sin x plus h. We are getting like this. Now x sin x into 0 plus x cos x into 1 plus sin x plus 0. Since we know that the limit of we know that what, since, just write here, since limit x tending to 0, 1 minus cos x upon x equals to 0. Okay. And limit x tending to 0, sin x by x equals to 1. Clear? So this is equals to 1, this equals to 0. 1 minus cos x, so you can take minus sign outside and that will be 0. So finally 0. So this is 0, that is we get x cos x plus sin x. So dy dx x sin x, this. Clear? So this type of derivative we are getting from first principle method. So just write its answer here. First, dy dx x sin x is equals to what? X cos x plus sin x. Okay, we get this from first principle method. Now, by using product rule, just we know product rule. What is product rule? UV dash. This is long method. Using first principle method is long method. Okay. Here, just second part. By using product rule, we get for fx equals to u into v, where u equals to x and v equals to sin x. d by dx fx equals to d by dx u into v. So what is the formula? U dash, or we can write derivative of first function u into second function v plus first function derivative of second function. This is our first product rule. Okay. So u means this is u, this is v. So in place of u, x. So here you can write d by dx of x plus into v. V what? Sin x. Sin x. Plus u means x. d by dx sin x. Since d by dx x to the power n equals to n x to the power n minus 1 and d by dx sin x equals to cos x. d by dx sin x equals to cos x. We know that. So it's this formula means what? Just like this. Suppose x to the power 5. Then what? So 5x to the power 5 minus 1. 5x to the power 4. X square. And what? 2 x to the power 2 minus 1. That is 2 x power 1. So here x power 1. So derivative of this what? N equal to 1. 1 x to the power 1 minus 1. 1 into x to the power 0. 1. So its derivative is 1. Okay. So just use it here. This is 1. Its derivative is 1 by using this formula. And sin x plus x into derivative of this sin x is cos x. So we get sin x plus x cos x d by dx of x sin x. So this is same as this x cos x plus sin x, x cos x plus sin x, same. So this is short method, product, or this is first principle method. So derivative can be found in this way also. Okay. Now derivative of polynomials. How can you find the derivative of polynomials? Polynomials means what? An expression having different power of x with multiple as a constant and addition. So polynomial function can be differentiated by distributing the derivative term by term. Okay, so remember that just like quadratic expression, cubic expression. Okay, so polynomial, if we are having polynomial of nth degree, just like this, suppose we are having a polynomial what? Px, x to the power n, its coefficient may be a plus a n minus 1, x to the power n minus 1 plus a2 a n minus 2 x to the power n minus 2 plus and so on a 0 or x to the power n minus n 0. So this is n degree polynomial. So derivative, this function of x also, this function of x also, derivative of polynomial, derivative of okay. So if this is polynomial, then derivative of fx, that is what? Derivative of px is polynomial. Derivative of, just write its polynomial here, an x to the power n plus an minus 1 x to the power n minus 1 and so on up to a1 x to the power 1 plus a0. This is polynomial. Okay, so we can distribute this derivative for finding polynomial derivative. Just distribute. Okay, as addition, this is added to this part. So again this is added to this part. Again this is added to this part. So we can distribute. So here d by dx of first part an x to the power n, d by dx of an minus 1 x to the power n minus 1 plus and so on, d by dx of a1 x dy dx of a0, constant part. Just distribute. Now here, differentiation, derivative. That's also constant term can be taken outside. Just remember it. Just like this, derivative of constant c fx. Then we can write c outside and derivative of fx. Linearity property, just like this. Okay. So here constant term can be taken outside of derivative, just like limit n dy dx x to the power n plus here also n minus 1 dy dx x to the power n minus 1 and so on. Here a1 dy dx x plus derivative of constant function is 0. Just remember it. Derivative of constant. Constant means value having no x without variable x is equals to 0. So this is 0. Okay. So here an by using formula dy dx x to the power n equals to n x to the power n minus 1. We can write here n x to the power n minus 1. Here an minus 1, n minus 1, x to the power n minus 2. Just use this formula. And here we can get derivative of x is 1, so a1. So this is the answer. An x to the power n minus 1 plus n minus 1, an minus 1, x to the power n minus 2 plus and so on a1. Okay, so this is derivative of px. Clear? So this is the technique of finding the derivative. When an expression is given, then you can distribute derivative and then find term by term derivative. Okay. So these are the method for finding derivatives. Just like suppose we have we want to find the derivative of any polynomial function. If fx equals to 3x cube plus 6x square minus 7x plus 3. If this is a cubic polynomial, then derivative of this what? Just dy dx write and write it 3x cube plus 6x square minus 7x plus 3. And how can we differentiate it? Directly as a rule for derivative of polynomial, we can distribute it dy dx 3x cube plus dy dx 6x square minus dy dx 7x plus dy dx 3. Derivative of constant is 0. So here just 3 take outside, dy dx x cube plus 6 outside, dy dx x square minus 7 outside, dy dx x plus 0. Derivative constant is 0. So here we see that 3 into 3x square by using formula n(x to the power n minus 1), dy dx x to the power n equals to nx to the power n minus 1. Using this formula, plus 6 into 2x square, so 2x, because 1 less, 3 minus 1 2, 2 minus 1 1, minus 7 into 1. So we get 9x square plus 12x minus 7. Okay. So this is derivative. Here we see that derivative is again a function of x. So derivative of polynomial of any degree you can find by distributing it and using this formula. Okay. Here one more questions for finding derivative by using first principle method is from this rule. Just see here, if fx equals to 1 by x, then find f dash x using first principle method. Okay. So dy dx fx. We know what is the definition? Limit h tending to 0. Fx plus h minus fx upon h. This is general definition, first principle method. So just find limit h tending to 0, fx plus h. Fx equals to what? 1 by x. So we can write in place of this 1 upon x plus h. We have 1 by x, so 1 by x plus h. This is equals to, and fx equal to 1 by x minus 1 by x. Okay, and distributed by h. Now limit, just our target is finding limit. So we are taking LCM, so we can get x minus x plus h upon x into x plus h upon h. Clear? So this can be solved. Limit s tending to 0. So x minus x cancel and minus h upon x cancel, minus h upon h, and x plus h. So just we are getting like this. Now here limit h tending to 0, just we see that h cancel, so minus 1 upon x plus h. Now we can put the value h equals to 0. So here limit h tending to 0, just put the value minus 1 upon x plus 0. Minus 1 upon x plus 0. So minus 1 upon x square minus 1 upon x square. Okay. So this is the derivative of 1 by x. Okay. This minus 1 by x square. So in this way you can find derivative of different type of functions. Okay. So do all the examples also and all these questions which I have completed now, and examples you have to do also. So complete all the examples and this all the questions which I have completed in your copy and send me for your attendance. Okay.